let's go ahead and work on finding factors. So we might have these instructions where it says find the factors for the number 14. Find the factors for the number 14. Now, the way that we're going to do this, let me explain it to you, is that we're going to go ahead and think about those multiplication facts where it is that we can get that answer as 14. So 1 times 14 is 14. 2 times 7 is 14. And there are no other numbers that we can multiply together to get 14. So what we say is we say that 1, 2, 7, and 14 are factors of 14. And so those are the factors of 14. You'll notice that I've listed the factors in order from least to greatest. Now the reason we can say this is because in the multiplication problem, both of those things that I've just written with red are called factors. And remember, 14 there is the product, and that's the number we were trying to find factors for. Here's another problem where it says find the factors of 18. Now, when we're thinking of this here, 1 is always going to be a factor of each and every single number. So we've got 1 here, and we've got 1 times what equals 18? Right, 18. 1 times 18 equals 18. Now we move to our next number, which is 2. We go from 1 to 2, and the reason that we can write 2 there is because we can write a multiplication problem with 2 to get 18. 2 times 9 is 18. Now 18, can we go ahead and do 3? Now, we can think about our division rules and divisibility rules. 18 divided by 3. Well, 18 divided by 3 is 6. So that 3 times 6 is 18. Multiplication is an inverse operation of division. And that's why we can think of our divisibility rules. Now, is 18 divisible by 4? No, it's not. 18 is not divisible by 5 because it does not end with a 0 or a 5. There's no 0 or a 5 in that ones place there. And then the next number up from 5 is 6. And yet we already have 6 right here. So we don't need to write down 6 times 3 equals 18. See if we did that. Let me just show you. We don't need to write that because we already have 3 and 6 as factors of 18. So at that point, now that we've gotten to 6, which is repeated right here, we know that we're done. We're done finding those factors of 18. The only thing left to do is to list those factors in order. Remember, these are the factors of those multiplication problems there. What comes first? Right, 1. And then we see 2. We see 3. And then we also see 6, 9, and 18. You might wonder and be all, okay, so how many factors are there of 18? We've got 1, 2, 3, 4, 5, 6 factors of 18. I'd like you to try to find the factors of 21. Go ahead and hit pause. Did you write down all your multiplication facts for 21? 1 times 21 equaling 21. It is not an even number, so we can't use 2. We can use 3 because 3 times 7 is 21. Can't have 4. Can't have 5. Doesn't end with a 5 or 0. Can't have 6. 21 does not, 6 doesn't go into 21 evenly. And then so we come up with 7. But we already have 7, so we know we are done. All we need to do now is we need to list those factors, and we list factors from least to greatest. So we have 1, 3, 7, and 21 as factors of 21. They are the factors of 21. Those are the numbers we can multiply together to get 21. Another strategy and approach is to use division, because that's the inverse operation of multiplication, and so it makes sense that we can use division to find factors as well. And I've been mentioning a bunch of division and divisibility rules. And to think, 20, we start with 1. 20 divided by 1 is 20. Is 20 divisible by 2? Yeah, it is, because it's an even number. 20 divided by 2 is 10. Is 20 divisible by 3? That means does 3 go into 20 evenly? Okay, if we use our strategy and approach, 2 plus 0 is 2, and 2 is not divisible by 3, so 20 is not divisible by 3. If I write this over here just to show you, that's going to be 6 with the remainder of 2, and since there's a remainder, it is not divisible by that there. 20 divided by 4 is 5. And then so if we wrote the next fact here, going up from 1, 2, and I had 3 right here, and 4, it would have been 20 divided by 5. But I already have 5 right here. So I know at that point that I'm done finding my factors for 20. All I need to do now is just to list them. And then so I list them. I see 1, I see 2, I see 4, I see 5, I see 10, and I see 20 as those factors of 20. The reason that this works is because if we did the inverse operation and we checked our work here, 20 divided by 1, it would be 20 times 1 equals 20. It would be 10 times 2, which equals 20. And it would be 5 times 4, which equals 20. And those, just like before, those there are factors of that multiplication problem. And we listed them in order: 1, 2, 4, 5, 10, and 20. Those are the factors of 20. It's your turn. Please find the factors for this number. Hit pause. And there's the problem. Find the factors of 27. Hit pause. Remember, there's always more than one way to solve a problem. Is 27 divisible by 2? It's not even, so no. 27 is divisible by 3. And then so 27 divided by 3 is 9. Is 27 divisible by 4? Nope, that would be 4 with a remainder of 1, so it doesn't divide evenly. 27 is not divisible by 5, because again, that ones place is not a 0, and it is also not a 5. Is 27 divisible by 6? Answer to that is no. 7? No. 8? No. 9? Whoops, we already have that. And then so we would come up with the same factors. So we're done. We just need to list those factors from least to greatest. 1, 3, 9, and 27. Those are factors of 27. 1 goes with 27 because 1 times 27 is 27, and 3 goes with 9. Those are corresponding factors. In our previous example, we had looked. I have a few terms for you. I have this thing called prime number. A prime number is a number that has exactly 2 factors. So for instance, 2 is a prime number. 3 is a prime number because the only numbers that you can multiply together to get 3 are 1 and 3. The factors of 4 are 1, 2, and 4. That's why 4 is a composite number. 5 is also a prime number because the only numbers that you can multiply together are 1 and 5. And we had 6 right here as a composite number, and 7 right here as a prime number, and 9 right here. Whoops, before that we have 8. We also have 9 here, because the factors of 9 are 1, 3, and 9. And since the factors of 9 are 1, 3, and 9, there's more than 2 factors. We also have 10 here as a composite number, and we have 11 right here as a prime number because the only 2 factors are 1 and 11. Now, to figure out whether a number is prime or whether it's composite, all we would need to do is we would need to factor that number, and then we look at those factors, count them up, 1, 2, 3, 4, up. 21 then is a composite number. Or example also from before, I think we did 24. Actually, maybe we didn't. But once we start listing out all of those factors of 24, we can very clearly see that it has more than 2 factors, making it a composite number. In fact, the only even number that's prime is 2. Now, one last thing to remember here, and you can watch our prime and composite video to go ahead and further understand this more, is that 0 and 1 are neither prime nor composite. 0 and 1 are neither prime nor composite. If we continued our prime numbers, it'd be 2, 3, 5, 7, 11. We'd have 13. We'd have 17. We'd have 19. We'd have 23. And it goes on from there. So that's where we're headed, the prime and composite numbers, and that's why it is that understanding how to figure out a factor is so important.